All right, 2010, number 6, no TI. We have dy dx given. We have the second derivative given. And let's see here. I know that f of 1 equals 2. Part A, write an equation for the line tangent to the graph of f of x at 1. So, equation of a tangent line. Y minus f of 1 equals f prime of 1 times x minus 1. So this isn't too bad. F of 1 is 2. That was given to me. That one I know. What I need to find is the derivative when x is 1. Well, they gave me the formula for dy dx, which represents the derivative, which is xy cubed. So I plug in 1 for x, 2 for y, that was given to me, and I do 2 cubed times 1, and I get 8. So there's the equation of my tangent line. Dy dx is equal to 8, so that's the slope. Not too bad. Part B. Use the tangent line equation to approximate f of 1.1, and given that f of x is positive, is the approximation greater than or less than? And explain. So, tangent line approximation. I'm going to use the tangent line that I just found, and I'm subbing in where I'm approximating, and I get y equals 2.8. If you recall, our approximations are always determined when we're asked whether it's greater than or less than the actual based on concavity. Concavity comes from the second derivative. That's why they gave us this formula for the second derivative. I need to find the second derivative at the given point. This is the point that the equation of the tangent line is from. If I plug in 1 for x and 2 for y, look at the second derivative. 2 cubed times 1 plus x is a 1, y is 2. Everything I sub in there, it's going to be positive. So I know at this point, the second derivative is positive, therefore my function is concave up. And if you recall, if my function is concave up and I have a tangent line approximation, my approximation is on the tangent line, the actual value is on the curve. So what you realize, the approximation is less than the actual value because the tangent line is below the actual curve. Hopefully that makes sense. Part C. Find the particular solution, y equals f of x, with the initial condition. They gave us dy dx. You know at some point they're going to make you solve for y. Here's our differential equation within an initial condition. Let's see what we can do. I start solving. I separate my variables. I get dy divided by y cubed equals x dx. I integrate both sides. Dy over y cubed is y to the negative 3. Add 1 to your exponent and divide. Make sure you have your plus c on one side. I rewrite this. Y to the negative 2 means that y squared goes into the denominator. So this right here is when I want to sub in my given information. So 2 goes in for y, 1 goes in for x, and you end up with negative 1/8 equals 1/2 plus c. Negative 1/8 minus a half. So what you're really looking at, negative 1/8 minus 4/8 is equal to negative 5/8. That's the value of c. So you want to sub that back in. So I'm subbing that value in for c. Now, I want to multiply through and get rid of my denominators. This is a mess. So I'm multiplying everything by 8y squared. Just be careful here. So then I end up with negative 4 equals 4x squared y squared minus 5y squared. Don't forget what you're trying to do. You're trying to solve for y, so we need to try to get y by itself. So I'm going to factor out a y squared, and I get negative 4 equals y squared times 4x squared minus 5, divide by 4x squared minus 5, so that I have y squared equals that fraction. Now I'm going to square root both sides, and of course I get the positive and negative version of the square root of that fraction. Now this is where I want to split it into the positive version and the negative version. If I split this up, y equals the square root of negative 4 over 4 times, I'm subbing in a 1 because that was my initial condition, that f of 1 is equal to 2 squared minus 5. Well, looking at this fraction, you end up with y is equal to the square root of negative 4 over negative 1, which is the square root of 4, which is positive 2. So when you split this, you get the positive version, negative version. The negative version you're going to reject because you have to satisfy your initial condition of f of 1 equaling 2, and there's your answer right there, the positive square root of -4 divided by 4x squared minus 5. That's your final answer.